Hi, my name is Jacky, and my thesis is about re-evaluating the current transport network of Christchurch and hoping to design a future solution. My thesis is in three parts. Firstly, I begin by looking at the past and present of Christchurch. Secondly, proposing an urban strategy. And finally, a building proposal that addresses the issues that I will be presenting to you shortly. So to kick off my research, I started with trying to understand how transportation technology is the main driver for the evolution of cities. What I found was that there was a close relationship between the size of cities and the transportation technology available. This was also known as the travel time budget, and it seems to be the principle for how people live in cities. This is also what dictates that cities can be no more than 1 hour wide. Transportation technology has often been the main driver behind our city's expansion. The top is the timeline with the past waves of innovation, and the bottom is its effect to Christchurch city size. As you can see, it has evolved from a walking city to a transit city, then finally at its current state, the automobile city. Therefore, my thesis focuses on the next stage of Christchurch. What will be the next technology that dictates the future urban form? How do we push Christchurch past the automobile city? Do we really want to keep expanding, knowing that petrol prices will only keep rising? So in order to do that, I began investigating the current issues on personal vehicles in Christchurch. Here in Christchurch, cars are a necessity. Without cars, you have no other ways of getting around. This has been problematic for many cities around the world, but how does Christchurch actually compare with the rest of the world? In New Zealand, it currently ranks at number 4 worldwide, with 615 passenger cars per 1,000 people. And when comparing between three major cities within New Zealand, Canterbury has the highest vehicle ownership at roughly 0.8 vehicles per person. This preference of personal vehicle ownership leads to high demand for road widening, leaving little money for public transport due to low demands. Hence results in low public transport patronage and services, leading back to high preference of personal vehicles, and this is currently the vicious cycle of the public transport. So how can we break this? I believe it can be done through using modern technology to effectively change our social behaviors. Because in most cases, the target problem isn't the amount of vehicles that we own, but the number of occupants that matters. In fact, 79% of all journeys to work are conducted through personal cars, but 95% of them have only a single occupant. Not only is this super inefficient, but it also takes up a huge amount of space on the road during peak times, hence the congestions. However, I believe there are ways we can change this, and it is a matter of shifting from our personal hyperconsumption to a more collaborated one. Now, the perfect example of this is that an average home power drill is used somewhere between 12 to 13 minutes in its entire lifetime. So why don't we all just rent a drill instead? Or perhaps rent out our own drill to other people and make some money from it. Inspired by this very same notion, I believe that car sharing acts exactly the same way. Except now the drill is the 3 vacant seats in your car. Car sharing is proven to have a direct impact on the number of vehicles on the road, therefore one of the simplest solutions for road congestions. However, as easy as that may sound, there hasn't been any easy way to do this. Car sharing has been reluctantly bypassed when prior organizing needs to be done beforehand. So in other words, it's a hassle. Therefore, as part of my thesis, I've designed a mobile application called KiwiGo. It's a smart commuting mobile application that tackles the single occupancy vehicles through real-time car sharing. It's about turning personal cars into privately run public transports, allowing drivers to actively rent out their vacant seats to others heading the same directions. KiwiGo will track your activity records, such as the amount of rides and vacant seats you have shared, the amount of carbon emissions you've prevented, and most rewardingly, the amount of money earned by car sharing. Drivers' performance can also be commented by other users. This way, everyone's input can help create a much safer and friendlier car sharing community. I believe this application can act as a catalyst for many future benefits of the whole transportation system, because it has the potential to spread virally amongst its car culture population and change the urban fabric. For instance, this is the aerial view of the inner CBD, and this is the spaces just dedicated to cars. They sum up to 56% of the total area in this picture. These amount of abundant cheap car parking available, it is no wonder that public transport are forever suppressed by personal vehicles. These car parks, if reclaimed, can then be utilized much more usefully, such as for housing, education, parks and recreation, innovation projects from my colleagues in the other presentations. This then brings me to my urban proposal. It is certain that the earthquake rebuild will result in an influx of workers. So, with this forecast in mind, it is very hard to ignore the lack of efficient transport when Christchurch faces impending population spike in the near future. So therefore, firstly, I'm proposing to revitalize the existing rail for commuter use. As the rebuild approaches, the demands for new land and new homes are expected to soar. The press has illustrated many of the existing and emerging subdivisions in the regions, which a lot of them are located near the increasingly critical north to south corridor. Therefore, the fact that there is already existing rail infrastructure gives Christchurch an opportunity and access to high quality and high speed transit. Secondly, the current bus network is underused. I think what's needed is a more simple system, focusing on key routes for frequent bus corridors. I have chosen the routes that are wide enough to change from a curbside bus lane to a medium bus lane. An example of this can be seen on the red dot shown on this map. This is Morehouse Avenue on the south side of the CBD. Its current layout of the 7 to 8 lane road can be improved by changing to a medium bus lane that offers dedicated space for public transport. On this map is my proposed public transport network. Rail, express bus, loop bus, and a more flexible local dial-a-ride and cycle lanes. Bike sharing stations will also take a huge part for this bike-friendly city. These will be part of the whole transportation network and scattered within the urban fabric. Better Place is a company that has built innovative networks for the electric vehicles to finally make sense. And the vital component is to have switchable batteries in these vehicles. Hence, having battery switch stations will also be part of this proposal. KiwiGo will also be deeply integrated with these public transport systems, for instance, locating bike or car sharing services nearby. It will also provide thorough information and choice of commute through multiple modes of transport. I have then arrived at the point of designing the transport interchanges to accommodate the various transportation modes that I have just proposed. And the initial concept that I wanted to achieve was, how do I weave together multiple modes of transport? So I began experimenting with paper strips and weave patterns, looking to devise a modular system to allow these transport modes to not only flow seamlessly together, but spatially woven together as well. So I started off with a basic form of 5x5 grid, then lift up the four corners to create the spaces underneath. This created spaces for 2-axis movement, and this form can be modular to be arranged in various ways. However, I thought that this form was pretty limiting and did not offer much flexibility. So I cut out the strip of this base module, but through different arrangements it created hierarchy of movements, as well as vertical circulation if placed on different levels. This is a more flexible system that can work in different scales because of its simplicity. I have also categorized my building proposals in 4 scales, ranging from small, medium, large, and extra large. Each of these will accommodate a different combination of transport modes. So let's begin with the small. I took a basic strip module that I had and lifted the 2 ends. It created what looks like a typical precast Super T section that's used for most highway constructions. But by placing 2 modules together, it created an elegant and minimal bus stop design that caters to both sides of the medium bus strip that I proposed as my urban strategy. Next is my medium scale design. I used the previous form, which was the T section, and by rotating at 90 degrees it created 3 separate spaces. If this form was to be used for a medium bus lane, the middle area will be used for dedicated cycle lanes, while the 2 outer spaces can be used for bus stops. Next up is the large scale. Again, I took the previous medium scale form and mirrored it. This created a larger tunnel that can be used for better place electric vehicle, battery switch station, and the leftover spaces will be used to store these batteries. The image illustrates how the 3 modes of transport, bike, bus, and cars, are woven together by the structure of this design. Next is the extra large scale. I placed the 2 strip modules along the 2 sides of the railway track, then extracted the outer edge of the module and lofted an arch over the railway. I then extended and widened the ends, which created interchange entrance. So with this form, the railway and the bike lane will run in parallel underneath the structure. The roof of the structure will be accessible, essentially making this form both a building and a footbridge that connects the 2 sides of the railway track. Then this is the visualization of this moment. The middle strip of the roof will be outdoor public spaces. And this is the visualization of the nighttime where the roof can be seen used for the public. And due to its self-sustaining structure, this module itself presented to be a flexible system and can be extended if required. This is an interior view of the arching structure. So I guess by now you're probably wondering, so where will this be? Where is the site? Well, even though this proposal are not site-specific, I have chosen an area that suits these various scales interchanges, which brings me to a case study for Papanui. This is a site that's marked as one of the key activity centres in Christchurch, hence has enough open car park for reclamation. This site also happens to be the crossroads of multiple modes of transport that I have previously proposed as my urban strategy. Therefore, this site is the perfect example for slotting in these small, medium, large, and extra large modules. And because of this flexibility of the modules, they can also essentially be plugged into any part of the city, depending on the transport mode it serves. So I guess to sum up my thesis, it is about rethinking our existing transportation network, identifying its flaws, such as the single occupancy vehicles, and resolving it by using existing resources that we already have, but in a much more efficient way. I hope after this presentation, next time you're driving, I urge you all to look around and count the number of single empty seats around you, and think about the huge potential and market that's presented to us each day as we sit through hours of traffic, trying to get to the same places. My urban architecture approach are both reflections of this issue that aims to push Christchurch into a multimodal city and towards a much more efficient economy. Thank you.